Okay, welcome to the video on atomic structure. And so without further ado, we're doing 21 questions on atomic structure and get ready. So they ask us the first question: what is the number of protons, neutrons, and electrons found in an ion 3 plus ion? So basically the number on top tells us its mass number, and its mass number is the addition of the number of protons and the number of neutrons. So that's why some textbooks call it nucleon number, because it basically contains the number of things meant to be in the nucleus. So it's nucleon number in some cases. So now ion here has also lost 2 electrons because of the 3 plus that is evident on it. So what do? We look at our periodic table and we see that an ion is normally has 26 electrons. But because it has lost 3, it now has 23. So we're stuck between these two options as 23. And now the number of protons and electrons in the neutral element are the same. So in a neutral ion, we'll have 26, right? And in that case, the number of protons will also be 26 when it's neutral. So that's why I'm leaning towards this answer. If you add these two, you should get 54. This is actually just an isotope of iron. Okay, so now let's go to the next question. So for the next question, a single phosphorus 32 nucleus can be produced when a single sulfur 32 nucleus joins with a particle X. In the process, a proton is emitted. What is the particle X? So we're producing this guy. So you know that you're producing this guy, right? When this guy, wrong position of the 32. When this guy comes together with X and gives us this guy and a proton. So a proton has a mass of 1 and a proton number 1. So we call this, let's just call it proton. We can write it in full for this case. And now bombarding with X. So now we need to know what is coming together. So I go to sulfur, I go to my periodic table and I look at what sulfur's proton number is. Sulfur has 16. I look at phosphorus and I see phosphorus is 15. And now I balance everything on this side. The masses should be balanced because in the equation there's the conservation of mass. Mass cannot be created nor destroyed, but can be converted from one form to another. So in our case, the masses here, which is combined 32 plus 30 plus 1, that would be 33, should be equals to the ones here. We'll just call this guy X and Y. So we'll say 3 is 32. So we need one more mass or neutron, one more thing in the nucleus to make the masses balance. So we know this guy has a mass of 1. And then we now also check the number of protons and electrons as well. This guy's 15 plus 1, that's 16. This guy already has 16 as well. So we know that it has nothing. It has no proton or electron. All it has is single neutron actually. So in that case, we know that this is a neutron. I don't know if my explanation made some sense. Okay. Drinking water may contain dissolved calcium hydrogen carbonate. How many electrons were present in the hydrogen carbonate ion? So basically you need to know that this is a hydrogen carbonate ion and has a minus charge on it. That's why when it comes together with calcium that has a 2 plus and HCO3 that has a 1 minus, they cross, right? And that's why HCO3 becomes 2 in the equation here. So now how many electrons are in that? So for that case, we just look at HCO3 and we go to the periodic table. And by the way, the anion, so it's going to have gained 1 electron. So we know hydrogen is 1, carbon is 6, right? And oxygen is 8 times 3. and then it's gaining 1 electron. So we do this. That is 1 plus 6 plus 24 plus 1, and that is 32. I hope my explanation makes sense, because hydrogen has just 1 electron, carbon has 6, oxygen has 8, but there are 3 oxygens, so 8 times 3, and then the 1 electron that existing is anion. So don't worry, also my questions are verified as well. Okay, so neutrons are partial electronic field. The mass of one neutron is relative to 1/2 of the mass of a carbon atom. Blah blah blah. Basically, what happens? What is its behavior? We know from fact that neutrons have a mass of 1, and they are not deflected at all. So when you have your plates, you're gonna have plates. Let's say this is positively charged, negatively charged. You have a beam that goes right straight through, that is your neutron. You have a beam that deflects towards the negative plate, that is your proton, and then your electron that deflects more towards the positive plate. It deflects more because it has lesser mass. So this is your electrons. Okay, now this next question is actually also going to test our ability to understand how this deflection takes place. Now, a beam of charged particles are deflected by an electric field. The angle of deflection is directly proportional. So the angle, I'm going to not name the angle theta, of deflection is directly proportional to its charge to mass ratio. Okay, good. In an experiment, the protons are deflected by an angle of 15 degrees. In another, protons has a charge to mass ratio of +1, okay, deflected by this. So in another experiment, they are deflected by angle y. We're finding the value of y. So now let's work towards it. Protons have what charge? What mass? Protons have a mass of 1, and they deflected 15 degrees. Right? Now we're looking at this guy has a charge of charge to mass ratio. Now its charge to mass ratio for a proton is 1/1, so that's why it's 1. But now the charge to mass of hydrogen here, the charge is -1 all over its mass, which is 2, will give us a deflection of y. So the charge to mass of a proton is +1/1. For a negative hydrogen atom, it will be -1/2 because the charge is negative and the mass is 2. So when you cross multiply these two guys now, you get a -7.5 degrees. So the answer for number 5 is B. Okay. In which species are the number of protons, neutrons, and electrons all different? So in this case, fluorine, the number of protons here is 9. So we say P is 9. Electrons is 10. And then neutrons is also 10 because 10 plus 9. So this is wrong. We look at sodium has 11 protons, 10 electrons, and 12, I believe, 12 neutrons. So all of them are different, 10, 11, and 12. So the answer is B for number 6. You can check one more example just to be sure. This one has 15 because there's no charge. This is 16 18, but 16 plus 18, yeah, that also gives you this. So now next question. The ion Y3 minus contains 18 electrons and has a mass number of 31. Y3 minus contains 18 electrons and a mass number of 31. How many protons does Y3 minus, protons and neutrons, does it contain? Oh, so it has 18 electrons. 18 electrons that have gained already 3 minus. So its original proton number will be 18 minus 2, which is 15. And now the mass number is 31. So mass number, remember, is proton plus neutron. So the proton is 15 plus proton plus neutron, give me mass number. So if I'm finding my neutrons, you can basically just do 31 minus 15, that gives you 16. So now we have 16 and 15, and that is A. Okay. Oh, sorry. Which pair do they contain the same number of neutrons? Okay, good. So you need your periodic table for this particular question. So you go to your periodic table and you check for boron, and carbon. Boron has is number 5, carbon is 6, lithium is lithium should be 3, beryllium is 4, a 3 and a 4, that's wrong. Let's look at this guy, a 5 and a 6. 6 plus 6 is 12, 6 plus 5 is 11, so this one is correct. Okay, which ion has both more electrons than protons and more protons than neutrons? So they're giving us more protons than neutrons, more electrons than protons. So for number 9, we look at D is actually deuterium, which is heavy hydrogen. It is an isotope of hydrogen. When it's lost one electron, when it's gained one electron, basically we're looking at a 2. So the electrons are more than the protons, yes, but are the protons more than the neutrons? No, there are no neutrons actually. In this case, it's not more. Now let's look at D actually. In D we have OH minus. So OH minus has how many electrons? It has oxygen that has about 8 electrons, plus hydrogen, which is 1, plus the additional electron is gained, that is 10. So that's 10 electrons. Now in terms of protons, it has 9, and in terms of neutrons, we need to add up its collective mass. Hydrogen having just a mass of 1, and oxygen having just a mass of 16. Okay, so mass of 16 plus 1, like 17. So that means, and the protons is 9, that means it has 8 neutrons to make a mass number of 17. So in this case, you see that the electrons are more than the protons, and the protons are more than the electrons. So 10 greater than 9 greater than 8. So that says D. Which species contains the smallest number of electrons? So with questions like this, it's easy for us to just pounce and say it's C, but then we now have to look at all the options because it's not C. Look at helium on your periodic table. Helium has 2 electrons, but it's lost 1, so now it has 1. This guy has 2, and then the rest you can just cancel out. So the answer is actually D. Don't pounce because you say hydrogen. Hydrogen is small. Okay, so sodium azide and this. So azide has a charge this, and sodium has a charge of this. So we're finding the number of electrons in both of them. So sodium has normally 11, but because it's lost 1, so it's 10. So it's between this and this. Now nitrogen is 7, I believe, times 3, which is 21. And 21 plus 1 is 22. So that's why the answer is B. Now we're going to isotopes. Isotopes, very beautiful concepts. They have very similar chemical properties because they have the same electronic configuration, but they differ because of the mass number is different. The electrons are still the same. So okay, now which pair of atoms are isotopes? Basically that's what the question is asking. Basically you look at it, which one do they have the Which number do they have the same number of electrons but different of everything else? So you see these two guys have the same number of electrons, but now what is different? So in 34 and this, they still have the same number of neutrons but different number of protons. Good. And remember, if they have different number of protons, then they are different elements. So 32 and 34, because proton number is just known as your atomic number. Your atomic number is what determines your position in the periodic table. So if I have an element 32 and an element 34, they are two different elements. They are not the same element anymore. And isotopes are of the same element. And so that's why the answer is W and Y, which is A. Okay. Technetium is a second row transition element that does not occur naturally on Earth. One of its isotopes has 56 neutrons. What is the nucleon number of this isotope? Okay, it has 56 neutrons. Okay, so what is the nucleon number? Nucleon number is just adding this and its proton number. So we go to our periodic table and then we look for technetium. They already told us where it is. Second row transition element. So basically technetium has an atomic number of 43. So what we're meant to do in a question like this is to do 43 plus 56, because protons plus neutrons give us mass number or nucleon number, and this is 99. Okay. When nuclear reactions take place, the elements produced are different from the elements that reacted. Nuclear reactions such as the one below are used to represent the changes that occur. The nuclear mass number total is constant at 236, which is agreed, and the proton number total is constant at 92. In another reaction, uranium-238 is reacting with deuterium atoms to deuterium, which is hydrogen-2,1, and isotopes of the new element J is formed. So this is basically the same thing we were doing before. The number conservation of mass, the mass number must remain the same, and the proton numbers must remain the same. So here we have a total of 240, and here we have 2. So we're expecting an element with also 238. We're expecting an element also 238, because in this case they will not be balanced. But then now we look at the bottom, 92, 91, that's 93. This guy has a 0, so expecting an element 93 too. So now we have 238, but then we now need to look at our periodic table to determine which element has 98. So you go to your periodic table and you go to the last period. I think it's you go to the actinide and the lanthanide series, and you will see the element that has 93. That is neptunium. That is A. Okay, sorry, I scrolled too much. Okay, good. GE 68 isotope is useful because it undergoes natural reductive process to give an isotope of a different element X, which can then be used to detect tumors. The transformation of GE occurs when an electron enters the nucleus and changes a proton into a neutron. Which of this is correct about the composition of this element? Okay. So for this one, we look at what it has. So they said 68 GE, some things happen and it comes to 68X. So one thing we must know, the mass number should be the same. But they mentioned something. They said GE, basically let's also look for GE on the periodic table. GE is germanium. Germanium has an atomic number of 32. Good. The transformation GE when an electron enters the nucleus and changes a proton into a neutron. So an electron enters and turns a proton into a neutron. Right, in this case, let's look at how many neutrons this guy has to make up. This has 36 to make up 68. Right? 36 to make up 68. But now an electron has turned into a neutron in this X. So that's 36 neutrons. So that means one of this guy goes down and now becomes this guy. And so in this case, it now becomes like 31, and then it still has 37 neutrons. Let's see. Is that clear? Clear. What is the electronic configuration of Mg2 plus? So for a question like this, you don't need to carry your periodic table. Mg has an atomic number of 12, but in this case it has lost 2 electrons, so it's 10. So you're working 1 s2, 2 s2, and a 2p6. We should all be clear on how this goes about true false principle. So 1s, 2s, 2p, 3s, 3p, 3d, and you learn about how this works. I'll make a detailed video on how this works later on. Where in the periodic table will an element that has this atomic shell come up? Okay, so for the period it is in, so it's in period 4, so we know it's between this guy, and it has 5 atoms electrons, so it's in group 5, or like some textbooks call it group 15. So we know the element is in D. In which pair of the species do both species have only one unpaired p electron? So you know, elements in the p subshell come like this, and each block can hold 2 electrons. So in this case they have only one unpaired, so it must have a, what's it called, a p5 for that to occur, a p5. So now we look at which one has a p5. So you can go to your periodic table. Actually, let me pull up the periodic table so we can see. We can pull up a periodic table. If we pull up a periodic table, we can look at which one has a p5. Okay, so looking at the periodic table, starting from this block, we have p elements, right? So we have a p1, p2, p3, p4, p5. So a p5 will be all these guys here. That will be a p5. So now we go back to the question. Only one unpaired. So which one belongs in that group? Okay, so I already see my fluorine. So my fluorine, I see my fluorine. And then also they mentioned gallium. Okay, so gallium too. So for it to have only one unpaired, it's either it looks like this. I'm so sorry for not pointing out, or like this, or just one electron. So in that case, it is fluorine and gallium. Which element has the same number of electrons as ammonium ion? Ammonium ion is like this. So you calculate it: 7 plus 4, which is an 11, minus 1, that's a 10. So which one has a 10? You know, it is neon. It's good to also keep your periodic table in your head. It helps you answer questions more quickly. Now, element X has the same electronic configuration as Kr. What is the electronic configuration of element X? So they said it has the same electronic configuration of Kr, of krypton. So you look at where krypton is on the periodic table. Krypton is a 36. So that's an argon ending with a p6. So we know it's argon and everything up to p6. So it's argon, 4s2, and then 4p6. 4s to 4p, then we go to 4p6. We can skip the things in the middle for now. So yeah, 4d10 and then 4p6. So we know number 20 is gonna be